Hello friends, today we are going to study about inelastic head-on collision. In the previous lecture we have studied about elastic collision where kinetic energy before collision is equals to kinetic energy after collision as there was no energy lost in the deformation. But in the case of inelastic collision there is some permanent loss of kinetic energy, and this loss we can say that is due to the deformation of the colliding bodies. Before collision, if you see the situation, the two objects are moving with velocities u1 and u2, and we assume that after collision they are moving with velocity v1 and v2. We can find out the value of v1 and v2 if we have given the initial velocities of the two colliding bodies and the coefficient of restitution of the collision. If we apply the basic concept of conservation of linear momentum to the above situation, we can say that the linear momentum of system before collision is equals to m1 u1 plus m2 u2, and this should be same as linear momentum after collision, which is equals to m1 v1 plus m2 v2. Now we apply the concept of coefficient of restitution. We can say that coefficient of restitution E should be equals to velocity of separation v2 minus v1 divided by the velocity of approach u1 minus u2 to this problem. So by applying the two basic equations of conservation of linear momentum and coefficient of restitution, we can find out the values of v1 and v2, the velocities of two colliding bodies after the collision. Now if we state the key points regarding the inelastic collision, we can say that the linear momentum of system is conserved along the line of impact before collision, after collision and during the collision, as there is no external force along the line of impact. If we think about the kinetic energy, we can say that as there is some energy lost in the deformation, we can say that kinetic energy before collision is not equals to kinetic energy after collision. Some part of kinetic energy is lost in the form of deformation of the colliding bodies. So we can say that some energy is lost and the kinetic energy before collision is not equals to kinetic energy after collision. If we try to find out the expression of kinetic energy loss in this case, we can say that the kinetic energy of system with respect to center of mass before collision is equals to half mu into v relative square before the collision, which is equals to half m1 m2 upon m1 plus m2 into u1 minus u2 square, and the kinetic energy of system after collision is equals to kinetic energy of system with respect to center of mass is equals to half m1 m2 upon m1 plus m2 into v2 minus v1 square. And if we see the expression of v2 minus v1, we can say that v2 minus v1 is equals to E times u1 minus u2. So by this we can say that v2 minus v1 square should be equals to E times into u1 minus u2. So v2 minus v1 square should be equals to E square into u1 minus u2 square. So kinetic energy lost, we can say this should be equals to the initial kinetic energy of system with respect to center of mass minus final, which is same as half m1 m2 upon m1 plus m2 into u1 minus u2 square into 1 minus E square. In the simple form, we can say that the expression of kinetic energy lost is same as half mu v relative square into 1 minus E square. So we can use this expression to simply find out the kinetic energy lost during an inelastic collision, where we have given the value of coefficient of restitution E. If we use the above concepts in a particular problem where there is a mass small m which is given some velocity v0 and it collides with a stationary object of mass 2m, and it is given that the coefficient of restitution of collision is half, we have to find out the value of velocity of the two blocks after collision and kinetic energy lost during the collision. If we say by conservation of linear momentum, the linear momentum of system before collision is mv0 and after collision mv1 plus 2mv2. So by conservation of linear momentum, the two values should be same, and by conservation of by the value of coefficient of restitution E, we can say that E should be equals to velocity of separation, which is equals to v2 minus v1 upon u1 minus v2, which is same as v0, and this should be equals to half. So by this we can say that v2 minus v1 should be v0 by 2, and by equation 1 we can say that v0 should be equals to v1 plus 2v2. By using above two equations, we can say that 3v2 comes out to be equals to 3v0 by 2, and v2 comes out to be equals to v0 by 2, and also v1 comes out to be equals to 0. So we have found out the velocities of two blocks after the collision, and if we try to find the kinetic energy lost during the collision, we can apply the expression of kinetic energy lost which we have derived above. We can say that kinetic energy lost equals to half mu, which is equals to m2m upon 3m into v relative square, which is v0 square into 1 minus e square 1 minus 1 by 4. So this comes out to be equals to half into 2m by 3 into v0 square into 3 by 4, which is same as m v0 square by 4. If we try to find the kinetic energy by simply writing the kinetic energy after collision and kinetic energy before collision, we can say that kinetic energy after collision is half 2m into v0 by 2 ka square, which is same as m v0 square by 4, as the first block comes to rest after collision, and kinetic energy before collision is half m v0 square. So the kinetic energy loss should be equals to change in kinetic energy of the system, which is equals to half m v0 square minus m v0 square by 4, which comes out to be equals to m v0 square by 4. So the kinetic energy loss find out by the two methods, by simple method and by using the expression of kinetic energy loss. These are exactly same. Thank you, my friends.